welcome everybody to Games with Go, episode 30. Today is mostly going to be some cleanup and bug fixes, and we're also going to finish up, or at least partially, or work on our text UI, where we're rendering the events that have happened in the game. And if anyone's joining who's new, you can visit the website. And there are some handy links that will take you to either all of the past episodes, or there's a page that will show you past episodes kind of by topic. So if you've just joined lately and aren't sure how all this stuff is working or what the point is, you can go there, check it out, see the old episodes, learn some stuff. All right, so I've got a list here of things I'd like to accomplish on stream. Hopefully we can get to them all. First thing I want to do is we've got a bug that appears only on Mac in our threaded UI game setup. So we set up our game to run the game logic in one thread or one Go routine, and to run the UI in another. And we also set it up so we could use any number of UIs at the same time. So one problem with this is that on a Mac, the input polling, which is here in our UI loop, where we poll for events, on a Mac you're only allowed to do this on the main thread. And Go routines can move between one thread or another unless you specifically lock them to one thread. But they need to be more than just on one thread. They need to be on the main thread anytime you call a poll event. And that made me realize another problem we have is that it's really not correct to have multiple UIs running and calling poll event because they're polling all of the events on the whole system, not just events that happen in one window. So if we want to support multiple UIs at once, what we really need to do is have like a separate thread that's all alone just for the input polling, and then have the display be in the UI. So we would want to move this whole part, this whole event polling and checking stuff into just one separate component of some kind. We're not going to do that right now, because that'll be a lot of work and add a lot of complication. For now, we're just going to say that there's only going to be one UI for now. And so when we get to the point when we actually want to support multiple UIs, if we want to support multiple monitors, then we'll need to refactor the poll event into its own component. So when we need multiple UI support, refactor event polling into its own component and run it only on the main thread. But for now, what we do want to do is make this work on Macs. And because the UI is running in a Go routine and not in the main thread, which is what starts here, it doesn't work on a Mac. But it's a pretty easy fix. Basically what we want to do, we won't need this loop anymore because there's only ever one UI, is we'll run the game in a Go routine. So we can say go func no parameters. So now we run the game in a Go routine, and we can pull the UI out into the main loop. And we don't need runtime anymore because we're not going to call lock OS threads. Okay, so for us on Windows and Linux, there's no change. But now for Mac users, it'll work when it would not before. Okay, so that's the first thing off the list. Not too bad. So we'll delete that. So struct initializer syntax. So 2 episodes ago, I was trying to make the new spider and new rat functions use the struct initializer syntax. So that's where you can, you give the struct name, use the curly braces, and you can say like, field 1 equals 2, field 3 equals 4, and so on. And it wasn't working. I didn't know why. So it turns out when you have embedded structs, right? So our monster has a character struct embedded. You actually have to specify each embedded struct. So to do a monster, we'd have to say character, character, and then do all the things inside a character. And like it had an entity had a position. So basically it becomes a big mess because we have quite a few embedded structs going on to make up a monster. So we're not going to do it that way. We will just leave it the way we've got it, where we make a monster then fill in what we want. But that's why this wasn't working. So we can cross that off our to-do list. Okay, so our event displaying UI, we just sort of proved that we could make it work, but it is total nonsense right now, right? It takes up the whole screen with a huge font. So let's fix that up. So the first thing we should do is make the font smaller, probably. So let's see, how are we drawing that? It's going to be in our UI's drawing function. So probably up in here, where's our new UI? Okay, so we're making all of our fonts here. So inside draw. Okay, so in draw we're going through our events and using font large. So let's just make this font small as a start, just to see how big it is. I think that's maybe still a little too big. So let's go to our definition of font small. We're making it 24. Let's try 18. All right, that's probably a better size. And the other thing we'll want to do is not render it on the whole screen, but maybe make a little box in the bottom of the screen and draw it there. Okay, so we're starting at 0 currently. So a good thing to do when you're doing UIs, if you want to support multiple resolutions, is try to think of everything in terms of percentages, right? So we don't want to start rendering our text at like pixel 800. We want to do it at some percentage of Y. That way, if someone resizes the screen or uses another resolution, it'll still work or make sense, at least most of the time. So let's do something like that. Let's say that the text start Y is going to equal the window height times 0.75. And we'll need to cast. We just use float, yeah. And then back to an int. All right. So now, so we used the index we were at times 64 because the large font was 64 pixels high. This is only going to be 18. And then we'll want to add the text start. position. Let's go ahead and make this an int 32. So that's what SDLRect wants. Let's just take a look. Okay, great. So that is a little more sensible. Now the other thing we need to do is make it, well, a couple things we need to do is, one is the events should not build up forever, probably. So let's see where we're adding them. Okay, so currently we just have a slice and we're just appending directly to it. So we're going to have to build up a little bit of a system here instead. So what we'll do is we'll have this add event function. You just pass in a string. And how big are we making? Let's see, when are we making our events? Okay, so we're making it a fixed size. So what I think we need to do is make make events a fixed size that we keep it at. Say 10 or so. Let's see how many things fit in our little box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we'll make it 10, and then as you add events past 10, it'll remove old ones. Or maybe just overwrite old ones. So one way to do it is to treat it as kind of a loop. So like if we had events 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 happen, then the 11th event would just overwrite the 1, the 12th event overwrite the 2, and so on. So you only ever have 10 events, and it just can keep going in a circle. And then, so what we'll need is like an index into the current position of the events. So we'll have an event position. Maybe if the event system gets more complex, we might pull it off into its own struct, but for now it's just two things. We'll just leave it like that. So we'll start event position off at 0. Well, it's already going to be 0. Go guarantees that. And we'll make it 10 large. So now our add event function, we'll say we'll add 1 to our event position, then we check if that's gone too far. If that equals the length of the level.events, then we've gone too far. And the level event position will now equal 0. So that's how we'll get our wraparound. And then level.events, level.event position will equal our new event. So that may be all we need. So now this would just be add event player attack monster level dot add event. Okay, so probably the thing here now is we have nil strings. So we have our we have our slice of 10 strings, but not all of them have been set yet. So we need to make our UI check for that. So just here we'll say if event not equal to nil, then do our stuff. Strings can't be nil. Oh, text has 0 width. So I think it's just an empty string. There we go. Okay, so one bug I did notice is that we're starting at 1. So this should probably come after. Like that. There we go. And the other thing we need to do is when we render it, we don't want to render it. Well, let's add some more events first so we can see this improve. So monsters also attack players. So let's add this as an event. We can actually get the monster's name right. So okay. All right, so now we're like overwriting from the top as we get new events. We want to have it scroll upwards or something instead. So when we draw it, we don't want to just go in order. We want to start at the event position. So we're going to say for I is equal to level dot event position. Let's see, how do we do this? Yeah, so we go from, actually let's do it like this. We'll say I is equal to level event position. And we'll just have an infinite loop that we'll break out of. We need to check if we're past the end. So if I and if I, so if we get to the end, we need to wrap around to 0. If we get back to event position, I'm trying to think the least painful way to do this. Let's just go with this for now. So event is equal to level dot events of I. We render it, and we say I++. So I think here is where we can say, now if I equals level.event position, then break. So the basic idea is we start at event position, which is the beginning of our events. If we get to the end of the slice, we wrap back around to 0. Then we draw that event, add 1 to the next event, and if we get back to event.pos, then we've finished. So I think this should give the scroll up effect. Can I do a modulus on the length there? Yeah, you could just say that, I think. Let's try it. Index out of range. It's going to print out I so we can see where it's going. So it got to 10. I think we need to do -1 because we need to go 0 to 9. Why isn't that happy? Yeah, it should be. Oh. There we go. All right. We were blowing up. We've got a logic error in here somewhere. Let's see. Let's see here. This is wrapping around to 8. It looks like. Okay, that's weird. All right. So let's try I want to test this a little more. Where's our main game loop? Let's see, what do we need to get I to A? Can we just do that? No. We need string convert. Oh, count plus plus. Okay, it's not scrolling the way I intended. It's going top down. Okay. So let's revisit this in a little bit. So we can work that out. And another thing I want to do eventually is have the text have kind of a like faded box around it with some alpha, so that when it's, you know, if you go over to the right side of the map, it's going to be on top sometimes. So I want to put like a kind of dark, partially translucent box around it. It's like you can't read that right now when it's on top of things that are the wrong color. So that's another thing I want to do. So we'll give it a border and a background of some kind. Okay. Let's switch gears for a little bit. Look at some of the other to-dos. Functions for checking key presses. This is an easy one. Currently, to check if a key's been pressed, we're having to do all this stuff. And it's real easy to make a function that can just check this. So we'll do the UI receiver. And then we want to check a couple different things. One is whether a key has been pressed down once, which is what we want to use for movement for sure. And that's the logic where as soon as the key is pressed down, you do something, but then you don't repeat it until the key is pressed again. But you don't wait for the key to be released before you do a thing. So we'll say key down once, it'll return a bool, and then it takes one of these SDL scan codes. What are these? These are Unknown types. Oh, they're just uint 8s. That's easy. So that's our key. So let me just take this logic. Return it for that key. All right, that's all there is. And then we may eventually want some other ones. So key pressed. So that will be when the current key is no longer pressed, but it was previously. And that we might use for other functions where having responsiveness is less important. Just depends what you want to do. So now we should be able to replace all these things with key down once. Scan code up. UI. Down. Left. Right. Then I'm going to take this S out of here. We were kind of using that for debugging. I don't think we need that anymore, at least not right now. Okay. So that cleans things up and will make checking for key presses a lot easier in the future. Okay, the attacking code. It occurred to me that I'm probably doing it in a silly way. Yeah, so when thing 1 attacks thing 2, I'm going ahead and like doing the attack and counter attack in one turn, and I don't think that's necessary. If a player attacks a monster, it'll attack it, then it will be the monster's turn, and if the monster has action points, it's going to attack the player. So I don't think there's any need for this at all. I think it's just going to lead to redundant attacking. So I was going to get rid of that. Then here we're going to have a new event. So let's see what that looks like. I'm just going to simplify it to one rat. So the logic's easier to follow. And then I'm going to cut down on the rat's hit points a little bit, otherwise it'll take forever. Oh, let's get rid of that move stuff for now. undefined returns 420 game. Must have dropped an S in there somehow. Okay, rat attacks us. We attack him, he attacks us. We attack him, he attacks us. Did I get the message that we killed him? I did not. So that must be because it's in the player logic. Okay, yeah. So this is kind of bad that we're repeating this check in both places, but maybe we need to because it's different turns. We'll stick with it for now. The other thing this event system will be good for is debugging. It'll let us see stuff more easily than just printfs down here. Okay. There is a typo. Yeah, needs a space there. All right, cool. We killed the rat. And we got the message. Okay, cool. So simplified attacking code, that was good. Action point bug. Okay, this is a fun one. So say there is a creature at the top of that hall behind a door. So Rockaport in chat says I can use a quick return in that move function to get rid of the else conditional. Which move function? Do you mean in here or the monsters? Oh, like this? Yeah, we could do that. I know that Go style kind of prefers that. To me, I'm agnostic, can go either way. What are these errors? Oh. Yeah, that's something that like Go linters will suggest you do. Okay, so we know there's a rat at the top of this hall. And when I open this door, it's right there already. So the reason that's happening, is because the action points are building up every turn. Every turn, the monster gets more action points. And so by the time I open the door, it's got a whole bunch and it can move all the way to me. So that doesn't make sense to do that. So what I was thinking we ought to do is have the concept of a monster being able to just pass on their turn. And so when they do that, they will use up action points equivalent to their speed. So we'll make a pass function. That'll be something we'll implement for the player too, because sometimes you want to pass your turn to, like, it can be better tactically so that you can hit the monster first instead of them hitting you first. So pass will take nothing and return nothing. So we'll just pull off speed from action points. And maybe in the future pass will have more logic to it. That's the reason I'm writing a function, even though it's one-liner. So yeah, that would be in the update loop. Yeah, here we go. I'm going to stop printing this because I haven't used this in a while. So what does A star return if there is no, let's see. So I want to see what the A star slice looks like when there is no path. Oh, I'm printing out way too much other stuff. Okay, so it's 0. So what we're going to say is if the length of the position slice is 0, and there's nothing we can do, so we're just going to pass. And then return. So hopefully, cool. Now that makes sense. Okay, now we're on to the hard stuff. So I noticed while playing around with it that if I made a whole bunch of monsters, this room is bad news now. Okay, there's one problem. I'm being attacked and nothing can actually attack me yet. So let's see why that's happening. So this is the move function. Make sure that no monster's in the way, and that the player is not in the way. Oh. Okay, this is obvious. So I'm checking to see if there's a monster in the way, and if there's a player in the way. And what this means is that if there's a monster in the way, it thinks it can then attack the player. So we need to make sure that you only attack the player if our to position is equal to level.player.position. So if we're trying to move on top of the player, then we attack him. Otherwise, we do nothing. All right, that's better. Now we're being swarmed. We're sure to be killed. All right, let's see if that fixes the fast key press bug. No, okay, that's cool. Or interesting anyway. So when I hit the keys really fast, the UI locks up. But I'm not sure why. So let's try to figure out what the deal is. I'm going to clear out some of this other output so we can do some debugging on it. So the problem's probably in here somewhere. I wonder if the problem is if I get a key press, 2 key presses before I get a response back from the game. That's probably the problem. Just as a sanity check, I bet that delay will fix it. So that seems to fix it. And it's still fixed. So they call bugs like this sometimes that are intermittent Heisenbugs, after the Heisenberg uncertainty principle. So we are back to 10 here. What if we're try one more time. Nope. Okay, we'll have to just keep that one on our radar. But I suspect the problem has to do with our channels. If we yeah, because we don't block and wait for new, we don't block when we wait for a new level. So if we got a key press, skipped this because there was no new level ready yet, and then got another key press, this would be blocking because these channels are not buffered. You can't put more than one thing on them. So if the game hadn't unloaded it yet, this would get stuck. And then we could never empty this. So why aren't we blocking on this? Why would we care? Let's try this. That's definitely no good. All right, I'm going to put a to-do on this. And another option to combat this is to make the channels buffered, which means you can put multiple things in them. But that's just kind of kicking the can down the road sometimes. Like, it just means you need more key presses to make it go wrong. You'd rather just never go wrong. So chat asks, in what order do the monsters move towards the character, and what's the algorithm for the movement? So as soon as the player is done moving, all of the monsters move, and currently their order is not defined. It'll effectively be randomly, not entirely randomly chosen, but we're iterating over a hash table of all the monsters, and that isn't guaranteed to be any particular order. And the algorithm they use is they use A* search. So when it's a monster's turn to move, it uses A* search to find the fastest path to the player and goes in that direction. And that's it. So then the next monster will go, and so on. So if you're that just made me think of something. I don't know if A* currently routes around other monsters or not. Like, I think right now, if a monster could get to the player, like this one may just be finding this path straight through rather than routing around. Which can actually make sense because the monsters are going to move out of its way anyway. But that's something to look at. Like, these guys are just getting stuck when they could cart. They should start coming around the corner. So that's something we should probably update. So we'll make a to-do for that too. And the way we'll change that is we'll make our A* not consider, if a tile's got a monster in it, then A* will consider that as the same as a wall or something. It won't try to route through there. So good question. Okay, so this one's still a problem. And then our UI is going the wrong way. And we need to add, well, we've got to-dos for that in here. So we've got 5 minutes. While we're here, let's add a little bit of a background to the event area. So I'm going to steal a function we wrote back in the Evolving Pictures project, which is, it gets a single pixel texture. This is a quick way if you just need a rectangular texture of a solid color. You can get it just with a single pixel that you stretch to size as needed. So we'll put this on the UI. That's where we'll get our renderer, create a static texture. We pass it a color, and it just fills in a single pixel, the RGB and A, with the color that we pass in. And it updates that texture and returns it. So that's a handy utility function. And then we will add a event background texture to our UI, and we'll set it when we create it. Event background. What do we just call this thing? Get single pixel text. And we'll do a let's see, it's going to be black, but with a partially transparent. Okay, then when we draw, where's draw? So we'll draw the background first, and then the text on top of it. And the background should be, yeah, on top of the level. So it'll be here. We'll say, event background texture, and nil for the source, and then we give it a destination rectangle, and that's how we stretch it, by giving it the rectangle. So we do 0 to text start. Then how big should it be? We'll do 25% of the width of the screen. So the width will be text width, and the height will be the win height minus the text start. That'll be the leftover pixels. UI.win height. And I think we need to make all of these this needs to be int 32. Comma. Oh. There we go. I need to get rid of some monsters to get over there. Okay, so yeah, now we see the border, but it is completely black. I bet we don't have, we do have alpha blending happening. Oh, we got to set it on the texture. So blend mode is per texture, it's not a global setting. So UI dot event background, set blend mode. There we go. Let's put some monsters back on and see what the text looks like. Cool. So there's some additional refinements we could do, like we could come up with a fancy border image to use, probably add some spacing away from the edge of the screen, but that will function for now. So the last step is just make the scrolling work the right way. So that's something we'll do real quick next episode. And then the other thing we're going to do next episode is we are going to do line of sight. So right now we can see everything on the screen. We're going to make it so you can't see behind closed doors or obstacles. Maybe give some sort of radius, how far you can see, and do like a fog of war. So as you travel through the map, you'll still be able to see the parts you've explored, but not the parts you haven't. And we'll have to do like two-dimensional ray tracing, I think, to figure out what you can see. So that'll be a fun algorithm to implement. So today was grunt work, which you have to do all the time in programming. Next episode will be a little more fun. We'll get to do ray tracing. Any questions about today? Any questions about this episode or previous episodes? Someone in chat is asking about the maps. We do have a super advanced level editor system called Notepad, or any text editor you like. So you can just build your levels. Another thing we're going to work on soon is being able to connect multiple levels together. So you can have like a staircase in one level that brings the player to a staircase in another level. We'll be able to have some system where we can define how all those connections work. All right, everyone, that's it for tonight. Thank you for joining, and I'll see you on Tuesday. And I think Tuesday I'll be traveling, so I'll be on my laptop, but I'll bring my microphone this time, so the sound should be okay. All right, good night, everybody.